Hello everyone, welcome to MSc Standard Institutions YouTube channel. In this session, we will discuss about heat pump VRF cooling mode. VRF VRV systems are usually classified in three types. First, cooling type VRF. Second, heat pump VRF. Third, heat recovery VRF. So today we are going to study about heat pump VRF. Heat pump VRF usually at a time can cool a building or can heat a building, but simultaneously they cannot cool and heat at a time. Either can cool or can heat. So today in this session we are discussing about the cooling mode of heat pump variable refrigerant flow DX system, which is a centralized system in DX. Okay. Right. So we'll start. First of all, this is the complete scenario which I have given to every one of you. I have taken two pens. One is black, other is blue. Black is complete refrigerant cycle. Blue is complete control scenario. First, we will be covering the refrigeration cycle. So I will be starting with DC inverter compressor to explain every one of you regarding the refrigeration cycle of heat pump VRF cooling mode. See, cooling or heating is done with the help of your four-way reversing valve, four-way reverse valve, four-way reversing valve. That this valve will carry out switching of modes, cooling or heating. So we'll start this with our refrigeration cycle. So I'll start with DC inverter compressor. DC inverter compressor, why we are using it? To have a control on the refrigerant flow. Variable. If you want a variable refrigerant flow, that means if you require a control over the flow of refrigerant, then you need DC inverter compressor. Why we require the control over the refrigerant or the variable refrigerant? Because in your DX system, which is VRF VRV, you have n number of indoor units with different capacities and different CFM, different TR values. So their needs are different. So as per their needs, the compressor should act. That's the reason why instead of taking usual compressors, we will be using in VRF VRV DC inverter compressor, which will be acting with the help of EVI sensors, enhanced vapor injection sensor. We'll study about these two. So I'll start my cycle. DC inverter compressor usually does three things. Any compressor: suction, compression, discharge. So this is the discharge line of your DC inverter compressor, okay, which will be discharging high temperature, high pressure gas. But due to lots of pressure which is being ejected by the compressor, oil from the crankcase of the compressor will come out via this refrigerant pipe and will go to all the cycle. Not just high temperature, high pressure gas will come out, even the oil will come out. So, such as to give back the oil to the compressor crankcase, here we are providing a oil separator. This oil separator takes the oil which is being ejaculated, which is being sent by pressure from compressor, will be taken by oil separator. Oil separator collects all the oil from the refrigerant and will give it back to your compressor. The refrigerant, high temperature, high pressure, hot gas without oil. Why? Oil is being given back to compressor. This particular high temperature, high pressure, hot gas will be traveled to four-way reversing valve. Here the mode is cooling mode. In cooling mode, these two connections will be off. This will be on while heating mode. In cooling mode, these two connections will be on. So our refrigerant, which is high temperature, high pressure, hot gas, will travel from the four-way reversing valve to the condenser HEX, heat exchanging coil. What is entering into our condenser? In our condenser, high temperature, high pressure, hot gas is entering. As it is a coil, definitely when a high temperature, high pressure refrigerant is traveling via a coil, automatically its pressure gets decreased. We know whenever a pressure decreases, automatically the temperature of that refrigerant also gets decreased. So when this high temperature, high pressure, hot gas is traveled via the coils of heat exchanger which is present in condenser, definitely there will be a reduced in temperature pressure. As the pressure is reduced, automatically high temperature converts to medium temperature, high pressure converts to medium pressure, hot gas converts to condensed liquid. Output of condenser is condensed liquid. Input of condenser is hot gas. This medium temperature, medium pressure condensed liquid will be given to NRV. What is condensed liquid? Condensed liquid means large amount of fluid and minimal amount of gas. Means mixture of majority of liquid, minority of gas. That's what we call it as condensed liquid. This condensed liquid will be passed via NRV, non-return valve. Why it is passing through NRV? Because the position of the gas and the position of the valve are same. So NRV will not oppose the flow of refrigerant. It will bypass this refrigerant from here to PHE. That means refrigerant will not enter into EV during cooling mode. Okay? It will travel via NRV. Where it will be traveling? To PHE. Plate heat exchanger or subcooler. What is happening over here? More condensed liquid. That is nothing but the condensed liquid which is coming from condenser passed via NRV given to PHE, plate heat exchanger. What it does, it even reduces the quantity of gas which is been mixed with liquid. PHE has been applied to reduce the temperature of the incoming condensed liquid. When you reduce the temperature, automatically you will find less gas, even more quantity of liquid. So that's the thing happening over here. This condensed liquid, more condensed liquid will be converted into reduced temperature, less condensed liquid. Okay? This less condensed liquid, reduced temperature means quantity of gas has been decreased as it is passing from PHE. As this more condensed liquid passed from plate heat exchanger, what will happen? The output of PHE will be reduced temperature, less condensed liquid. So the quantity of gas even get more reduced when it is being passed with PHE. This piping, this refrigerant piping, okay, of your refrigerant will be given to your EEV. This refrigerant which is in less condensed liquid state will be given to electronic expansion valve. This electronic expansion valve will even further reduce the pressure of the refrigerant which is entering into it. As the temperature gets even reduced, this less condensed liquid will totally convert into pure liquid. Low temperature, low pressure liquid. This low temperature, low pressure liquid will be given to IDU. One more thing, here the refrigerant which is reduced temperature, less condensed liquid will not enter into NRV. Why? Because it is in opposite position to the valve which is been placed. The position of fluid is this and the position of valve is this. So NRV will never allow the refrigerant to flow in this direction. Rather, the refrigerant will flow from here to the EEV. The EEV will reduce the pressure of the refrigerant. Due to that, this condensed liquid will be converted into pure liquid. This pure liquid will be given to the heat exchanging coil of evaporator. Okay. What is happening? It is in the room or in a space, right? Our IDU, indoor unit. What happens? The room rejects its heat. The room rejects its heat to the hex heat exchanging coil, which is evaporator coil. Whenever our room is rejecting its heat, because the law, what is the law? Heat transfer from higher body temperature to the lower body temperature refrigerant. So heat transfer is taking place. Due to that, our room will achieve 22 degrees Celsius controlled temperature, but the refrigerant which came in the form of liquid will convert into condensate gas. The refrigerant which entered into our IDU was in liquid state. Due to heat exchange, due to ejection of heat, due to the heat will be rejected, will be given to the refrigerant from the room due to heat transfer. What happens? This liquid will convert into condensate gas. This condensate gas, medium temperature, medium pressure, condensate gas. What is condensate gas? Large amount of gas, minimal amount of liquid. Okay, this condensate gas will be collected from all the three branches of IDU. Three branches of the IDU will be given to the main refrigerant pipe, and this is a suction pipe of compressor, right? This was a discharge, this is a suction pipe of the compressor, and this is a two pipe system. Our VRF is two pipe system. So the outlet of IDU is 18 degrees Celsius, medium temperature, medium pressure. Condensate gas is being flowing from the branch of the output of the IDU to, check out, just follow my pen. Okay, it is coming from here till here it came. From here it is been entering into your four-way reversing valve. From where we are coming? From all the branches. It's been started. We are bringing this medium temperature, medium pressure condensate gas from the four-way reversing valve. From the four-way reversing valve to your accumulator. What happened? From IDU, the return refrigerant is been coming from all the way from four-way reversing valve to your accumulator. Then what is the role of accumulator? Accumulator accumulates two things. It collects two things from the refrigerant pipings. Okay, one is condensate gas, next is oil. Whenever compressor is working with high temperature, high pressure, when it's sending the gas, oil comes. That oil may remain somewhere in the pipe sections. So accumulator will collect all the oil and the condensate gas. We will not allow condensate gas to enter into the compressor. It may damage the compressor totally. We only allow pure gas without any particulates of liquid. Okay, we will be giving totally gas. We will not give condensate gas. So accumulator collects all the condensate gas. Liquid will be accumulated onto the bottom of the cylinder. Onto the top it will be having gas. This gas will be given back to compressor. Means we will not allow the liquid which is present in the condensate gas to enter into compressor directly. That's the reason why we have placed accumulator. It accumulates oil plus condensate gas, and it will give away pure gas to DC inverter compressor. Okay, from here again the cycle repeats, the same thing will happen. That's what we call it as refrigerant piping of heat pump VRF system. This is the refrigeration piping. Same again, from DC compressor to oil separator to four-way reversing valve, four-way reversing valve to condenser, from condenser to NRV to PHE to EEV to IDU, from IDU all away from the IDU again back to four-way valve, from four-way valve to accumulator from accumulator to again back to compressor. This is your refrigeration cycle which I have completed. Now, which was in black ink color. Now let's talk about blue ink. What's the funda of it? How the control is been taken place, right? So I'll start this one. This two, 1, 2. This two. Let me complete oil pipes. What oil separator is doing? It is oil. This one. First line. I'm just writing it out. One. This one. And this one. I'll complete this two for you first of all. These two piping. Oil separator, oil pipe. It is an oil pipe, purely oil pipe. Okay, this oil separator collects all the oil which has been coming from the compressor and again it gives back to your compressor crankcase. One more thing, why we are getting this coil? One coil is here, one coil is here. Two coils are there. It is just to reduce the pressure. Why? Because this pipeline is a high pressure pipeline. So as to decrease the refrigerant to a further level, that's the reason why they are keeping what they are keeping. They are providing a low pressure to reduce the pressure. Coil is being placed at this place and even at this place. Why we are placing coil only to these two pipelines? Because these two pipelines are high pressure pipeline. Why? This is been connected to the discharge point of the compressor. See, this is here the pressure will be low. Here the pressure will be high. So they are connected to the high pressure line. That's why a coil is been given here. And over here, because this is also before condenser, right? So here also the high pressure, high temperature pressure line. So as to reduce the pressure, one coil is been given here, other coil is been given over here. I hope I explained this part. Same likewise over here. Accumulator collects what? Oil. This collected oil will be given back to your DC inverter compressor. These two pipes I have completed. Okay, 1 and 2. What about number this 3? Let's complete this first of all. Okay, which is coming from right away from here. Okay, what is happening over here at PHE is reduced temperature of refrigerant we are entering over here. Okay, at PHE. What is happening? Here the temperature is more, here the temperature is less. Okay, right? So heat transfer takes place, and from here, if the refrigerant is pure gas, it will directly come and enter into your DC inverter compressor. But if it is not pure gas, it is condensed gas, so it will travel from accumulator and after that it will be given back to compressor. Again I am explaining you. Here what is happening? If the outcome of the plate heat exchanger is pure gas, if the outcome is pure gas, not condensed gas, then this pure gas directly will travel to your compressor. But if the outcome of PHE is condensed gas, not pure gas, if it is condensed gas, then it will not travel to compressor directly. It will go via accumulator. Accumulator will take all the condensed liquid onto the bottom and will give you back your gas, which is pure gas, to compressor. Hope you understood these two lines properly. I have explained you this line also, right? Asa, this line is very important. Now, the accumulator has the liquid, right? Which is refrigerant liquid, because it has sent the gas. Liquid is in the bottom. That liquid has to evaporate, right? How can we evaporate that liquid? By adding heat, right? To add up the heat, we are taking this hot gas. We are taking this hot gas and giving it back to the accumulator. Now, as this hot gas enters into the accumulator, that liquid refrigerant will also convert into gas and again will be given back to DC inverter compressor. Okay, hope you understood this session. Fine. And what about this solenoid valve, solenoid valve, solenoid valve? Understanding? These are the valve, electromechanical valves, which operate at a certain temperature. Then only that valve will get turned on and sends the refrigerant to the further pipelining. Means over here, if this solenoid, hot gas solenoid valve, if at all from this pipe it's getting hot gas, then only it turns on and sends the refrigerant back. If it's not getting hot gas, definitely it will not turn on. It will not excite the control circuit of the board, which is connected to every inverter compressor. Understanding? It is an electromechanical valve. It is an electromechanical valve. Okay. Hope you all understand. This one is electromechanical valve. Whenever it's getting hot gas, it turns on. Then what about this? If it is a gas, temperature will be set. Okay. If it's a gas, then only it gets turned on and the gas will get entered into the DC compressor. Whereas we have what can I say? That's it, na? These all are solenoid valve. That's how these valves perform. These valves are nothing but electromechanical valves which operates both electromechanically. Direct mechanically you cannot operate it. Means it's all and all about control valves. So this is the scenario, this is the thing which I have explained to every one of you, which is heat pump VRF cooling mode. Next lecture will be on heat pump VRF heating mode. Thank you everyone. Hope you like this session. Please do like, subscribe, share, comment our YouTube channel, all our videos. It will motivate us. Thank you.